Hi everyone, and welcome to yet another tutorial on how to use Arcgis Pro. Today we're talking about modeling, and specifically I want to talk about assigning values to your criteria. With values I mean whether something is suitable or unsuitable, also known as a 1 or a 0. We're making it binary. You can see a model here. This is an example that we've used in the lectures as well, and in my class during the practicals I've sort of taken you through this model before. But just sort of to go through the motions and do all the right things, I'm just going to go ahead and create a new model for this tutorial. And as always, when creating a new model, obviously it's up to you whether you create a model for each different criterion or whether you use one model and build all your criteria in the same model. That is up to you. But just sort of to start off with the model, first things we do is we add the data that we want. So naturally, sort of looking at the learning database, we have the research area and there's a couple of others here, but what I'll do first is I'll go snoop around in the database here a little bit. So by now you've probably started building up your model already, and you, or maybe not, and you've decided on your criteria and you've decided on your indicators and what all your extensions are going to be, and you're sort of just looking at how to start building a model. So step one, what are you interested in? Obviously research area, because that's the area of interest. So when we look at the rest of our database, and we go to database 2021, which is you can find on Moodle, you can download it from there and create a folder connection to it. You've gone through all these steps in the past few weeks, so by now you know how to do that. But let's go through this and see what we're interested in. One of the requirements of the exercise is to use a raster file. So we're going to use the land use map because I'm interested in land uses. And bear in mind, I'm doing something completely fictitious here, so I'm not sure what the outcome is going to be, but we're going to find out together. Another thing, I'll probably be interested in soil. So we're going to take the soil map here as well, and I would like to do something with buildings. So let's go ahead and grab the buildings layer here as well. Yep, that's buildings. Drag you right to here. Okay, so first things first, whenever we want to start sort of geoprocessing, whenever we want to start building a model, the first thing we want to do is sort of trim our data. So in lectures, I always mention it, I call it the cookie cutter. So basically we've rolled out our dough, which is sort of the big database, the entire thing, the data set in its entirety. And we're going to use a tool. In baking, we use cookie cutters, but in this case, we're going to use a tool called Clip, which you're familiar with as you've used that in the second week. Now, one thing that you also know is that there's different tools for vector and raster. Now, LGN7 up here is a raster file. The soil map and the top 10 NL buildings are vector files. If you want to know, by the way, how to tell, if you go into the database, you see a little sort of pictogram in front of each name. And if you see these little little cells, the raster thing, raster obviously being a raster, or you might see something like this one here, which is lines, or at the bottom there's points, or anything in between that is polygons. And we know that points, lines, and polygons are vector files, and raster is, well, raster. So getting back to this, different tools for different data sets. So if we go into raster, we need a tool called extract by mask. So in geoprocessing, we just type it in, and the first hit that we get up there is what we need. So, and I'm sort of trying to line these things up a little bit. There's a lovely auto layout tool here that you can use, which will automatically rearrange or arrange your model so that it looks nice and neat. But we can do that later on. It's tidying it up and making it all look pretty is something for the end stages of a model, not necessarily the early stages. Right, so now we've got our tools, our first tools in here, and we've got some data in here. What we're going to do is we're going to just simply, you can drag and drop. So if you select anywhere, click anywhere in your data and go towards the tool, you get different options. And LGN7 in this case being the rolled out cookie dough. Gets me hungry, isn't it? It's the input raster, right? The research area in this case is the feature mask data. So that is the extent, or also known as the cookie cutter, of our interest area. So we're going to link those up, and you can see now suddenly, rather than the thing being grayed out, you can see that the tools gain color and the output is also there. Okay, we're going to just double click the tool real quick, and you see that the output raster, we're going to name that. We're going to call that LGN7 research, or let's go GW for Grote Wielen, which is the research area. Okay, do that, and you can see automatically that the output is named LGN7 GW. What that does is, along the lines of sort of building this model, along the way, we can make sure that our outputs have decent names so that we can recognize them once they're all sort of stacked in our database, so that we can follow our steps easier and retrace them as well. I'm going to go ahead and right-click the tool and click Run, and you'll see this sort of script run, and there's lots of information there. Not necessarily too important there. What you can even do, most important, it says it's done, succeeded, cool. You can even click Close on completion, because then when the next time we do something, and we're going to do the same thing for the clip tool, where we do input, which is the soil map, the cookie dough, research area, which is the clip feature, also known as the cookie cutter, and for good measure, we're going to do that here as well. Inputs and research area is the feature. And we're going to go Run. You see, once it's done, it will automatically close down, and it runs really fast because it's a very simple operation to do. It's a very simple script. And if you want, you can auto layout now, and you see that things have rearranged a little bit. I like to space mine out a wee bit, so that's, I suppose, the reason why I don't do this all too much while I'm building my model. It sort of flicks things around again, and it's not my preference. But it's a possibility there. Right. Another thing to do, let's see, when we talk about raster is reclassify. Because reclassify is sort of the big edge up. Raster is really easy to calculate with, and reclassify is going to make it very easy. I'm going to take the spatial analyst tool, not the 3D analyst tool, the spatial analyst tool, and use the LGN7. What I've done, and you'll notice that, as this is an example, I want to show you good practices, of course, showing you that you can change the output of your names. I haven't done that here. Please do make it an effort to do it, as it does help you with data management. But seeing as this tutorial is not so much about building models, but more about adding values, I want to just sort of get through it and focus on what we're here for. So we're going to add the output, which is now our new input, into the reclassifier. We're going to open up the tool, and we're going to see what it tells us. Now, we have a reclass field, which is value. It basically gives us the options of, I mean, we could click omschrijving as well, which is another sort of a column in the attribute table. But we're going to go by value, just because values are easy to sort of work with. And click unique, which is going to calculate all the unique values, basically give you a list of the unique values that are found within this data set. And this is limited to, as I said, the Grote Wielen area, because if you were to do this for the LGN7, the bigger layer, it contains a lot more data and possibly classes that are not within the research area. But these are. So you can see we see 1, 2, 11, 12, 16, etc. These are all the old values. And here it suggests new values. So that's 1, 2, 3, 4, 5, 6. As we want to add suitable and not suitable, this actually gives us a heads up, because it allows us to do very early in sort of in our modeling. It allows us to add values 1 and 0, which is exactly what we want. So I'm not entirely sure what these classes are by heart, but what I'm going to do is I'm just going to sort of click through. I'm going to make this 1, 1, 1, 1, go 0, 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0. Now, as I said, it's fictitious, so I have no clue what I've just done. It could make no sense whatsoever. But just to sort of go through it, we've now designated that classes 1, 2, 11, 12, these are all suitable, 16, 18, 19, 20, and 22 are unsuitable, 23, etc. and so forth. We've designated suitable and unsuitable. So we're going to go ahead and click OK and run the Reclassify tool. Now, I'm just as curious as you are right now at what we've actually selected. So we're going to right-click our output and click Add to Display. And we could see that within sort of Model Builder in our table of contents, on our content view pane, whatever you want to call it, we now see values 0 and 1. Now, if we want to know what that looks like, we're going to go to the map. I'm just going to zoom in to where that is. Or if you're zoomed out entirely far, you can always right-click the outputs, zoom to layer, and will automatically set you to zoom and see the entire area. So, what have we done? Sort of going off guesses here, water has become unsuitable, which is somewhere in the middle here. We can tell by sort of minimalizing this or switching on and off. There's some grasslands here, which are now apparently suitable, seeing as they have 1. And just like that, we've added values 1 and 0 to raster data. Now, we're not done yet, and there's more to do just yet, but I want to show you the difference between raster and vector. So we'll go ahead and focus on vector right now. So select is what the tool is that we're using for vector files. So when looking at the soil map, for instance, I can imagine that I would want to be interested in certain soil types and not so much in other soil types. Maybe I'm interested in sand but not in clay. For that, we need to first select what is sand and what is clay, and create a new output containing that data. So what we're going to do is use the select tool and drop that just behind here. And see, now it's confusing. I have to retrace sort of where these arrows came from in order to find that this is the soil output and this is the buildings output. This is why naming your outputs are very, very convenient. It's a very good habit to get into. But we know it's the soil map, and we're going to go ahead and select the output from our clipped soil map as our input for our select. And we're going to go ahead and select where, and then select a field. So we're going to go by name is equal to, and let's say that I'm interested in sand. Okay. And I'm also interested in something else. So there's going to be an interesting case coming up here. We're going to add a clause, and it's going to suggest to where name is equal to sand and name is equal to, let's say, Pete. Okay, I can tell you right now that this is not going to work. And why is that? Because currently I'm telling the computer to look for a single feature, a single object that contains under the field name both sand and peat. Now we can go into the soil map, add to display, and what I'll do real quick is just pop up the symbology and go into unique values, name, add these values, look at the map. Now there is nowhere in this area that I can find an area that is both peat and sand. They simply don't exist. There's either sand or there is peat. There's the keyword, or. Okay, so we're going to go back and select, and we said where field name is equal to sand, add a clause, and, no, not and, we're going to go by or, name is equal to peat. And this will work. Okay, so we're going to go ahead and select sand and peat as being areas of interest. Now we're going to go ahead, right click, run that as well, and create our output. Cool. Buildings are just buildings, and I want to stay away from buildings. I want to create a buffer around the areas where there are buildings. So as the analysis tool buffer, I'm going to add that to my list as well. Use again inputs, and let's create make sure to set a linear units and which metric you want to go by. We'll go by meters, and we'll go for a 250 meter buffer. Okay. Now a good one to sort of remember is that you can dissolve And remember dissolve, which is literally sort of dissolving, taking away the lines, melting things together. As if you were to dissolve sugar in water, for instance, you sort of liquefy it. You can dissolve within this tool, and you can either dissolve all the output features into a single feature, or you can select this unique value. Let's go ahead and dissolve all output features into a single feature. Okay, I'm going to go do that. Right click and run this. And as you can see, dissolving takes more effort. Not only do you ask it now to create buffers around every single feature within this area, now it also has to melt those together all at once. Okay, so where we have our, I'm just going to go by showing what we've got now. This looks a little bit messy. So we've got 3 different things here. So let's organize this a little bit. We're not interested in LGN7 at the moment because we've already looked at that. And I've made a selection of buildings, and I've put a buffer of 250 meters around it, and I've dissolved them all together. So now you can see there's one big blob, which we can tell there's only one object ID, which is all of these, and these are all the buildings with a 250 meter buffer around them. All right, let's go to selection and have a look at our soil map. Also here we see, right, so there's different object IDs of peat, and there's some sand as well. Interesting. Let's work with this. Okay, so never mind how it looks. We're going to go back to our model, and we're going to just close these attribute tables here, and let's add values now to these outputs. Okay, so the soil that I'm interested in, that's the stuff that I'm going to build on. Okay, so let's go ahead and add field. And with add field, I also want to have, and these go hand in hand, calculate field. Okay, these two are important. They always go hand in hand. Again, drag and drop, input, input, and we can link these together. We're going to call it soil suitability, and make that a short field type. Remember, we're working with 1s and 0s, so that's just a short integer, and we hit OK. Let's run that. We have to run it first before we can calculate it. Now we're going to, in calculate field, select soil suitability, and it's going to ask us, hey, what value do we want to give that? These are the suitable values, so we're going to give that a 1. And run. Just to double check our output, we can have a look in the attribute table, and all of these now have a suitability score of 1. Now, one thing that I'm now interested in, and I'm actually, while I'm still here, going to add these to the model so that I can use these later for the buildings. But what we've just seen is we've got different, I'll go back to it real quick. We've got different object IDs containing the value 1. Preferably, we will want to have one object ID with the value 1. So we can actually do that quite simply, again, with the tool dissolve, which we know from the buffer tool that we just did, which melts things together. And we could tell in the buffer tool that we could select a specific value to dissolve by. Now, if we use a dissolve tool, which is basically the same as what you can do in the buffer tool, there's also a question for dissolve field. So if we hit the drop down menu there, you can select a value which you want to dissolve by. In this case, soil suitability, because that is going to melt all the 1s together, which is the things that we're interested in. So we're going to select that and hit OK and run that for now. Cool. We're going to forget about soil for just a moment and focus ourselves on buildings. Okay, so I noticed that the little shade under the tool had gone, so we're just going to run that before we continue. And you might have noticed already, I've added the add field and calculate field to the model, but I've not linked it up yet. Why is that? Because I just said I want to be away from buildings. So I can now make a decision to add the value 0 to these buildings, but I would prefer to add the value 1. So if I'm just going to go by the map here. Actually, I want to have the research area in here real quick. Let's add that. So if, and I'm just going to visualize this with color, the buildings are areas where I do not want to be, let's make them red, then by definition, everything that is currently green, you see green, should be the area where I do want to be. Agreed? So if the red is the area that we're not interested in, we could give it a value 0. The green area is the area that we are interested in, which I would prefer to give a value 1. But this is just colors. I mean, if I switch off the buildings layer, I've got the research area, which is the entire area. We just said that we're not interested in the entire area, we're just in the area 250 meters away from buildings. So let's go back to the model, and what we're going to do is we're going to remove or erase the buildings and their buffer from the research area. Okay, so we're going to make the buildings layer or erase feature, because that's the feature that we're going to use to remove itself from the research area, which is now our input. Okay, now I'm dragging these from the beginning of our model, sort of along the early parts of the model. What you can do if you want to keep it sort of simple for yourself, you can always copy and paste a research area and say, hey, I want to use this one, just to sort of keep it insightful. But that is completely up to you. There's no right or wrong in that. You can add research areas multiple times, seeing as you use them multiple times, or you could add it once and then have lots of lines coming from it and link it up with many different tools. But that is up to you. No right or wrong there. So, quick recap. The erase, we have as an input the research area, and from that research area, we're removing the buildings. Okay, so it's somewhat of a clip feature, but different. It's sort of an inverse clip, I suppose. So let's go ahead and run that as well, and it's just going to go and run it from the top, just to sort of go through everything again. And that's okay. You can do that. And once the dissolve is ready, we now have our output, which if we add that to the map, it is exactly an inverse image of what we just had. You see? If I remove the output that we just generated from the erase tool, you can see that is exactly sort of an inverse image of what we just had. So we just said that all these buffers, those are not the areas that we're interested in. So the pink stuff here is what we're interested in. Cool. That is something that we can link up to add field and calculate field. We're going to call it buildings suitability. Again, make it a short. Run that. And again, it's going to ask, hey, what feature do you want to, what field do you want to calculate? The building suitability, and that has a value of 1. And run that as well. Cool. So now we can look at the attribute table and see we have an object ID with building suitability. Okay, so we've now sort of reversed the giving of a value, whereas here in the initial sort of soil map, what we did was we modeled, and so I like to call it, we modeled a positive. So here we made a selection and we added the field, we selected what we do want to have, and then we added the field and gave that a suitability score. Whereas in the bottom string, what we did was we modeled what we don't want to have, and then we added a value to that. Okay, both ways work, and in essence what we've come out to is exactly the same. Two features containing both suitable areas, or in this case 3, because the raster is also still there, but we're focusing on the vector right now. And we can now continue our model just as is. Okay. Now the reason why, and that's when I'm going to sort of wrap it up for this one, the reason why we want to model a positive is because of this union tool that we have here. I'm just going to move this to the top just to put it in the middle. Add a union at the back of our model. I'm just going to copy paste that. As you can see, it's sort of getting a little bit more messy, so what we can do is we can use the auto layout in just a second here. I'm just going to add these up. So let's input these, and what we want to do is we want to add a research area. So the union tool combines, and it forcefully combines two different layers. So do the same thing with the buildings, or with what's left of what used to be the buildings, building criterion. We're going to add what we just calculated as to be value number 1, same counts for the soil map, add that to union together with the research area. And in union, there's one setting that I want you to switch off, and that's under attributes to join. Rather than all attributes, we're doing all attributes except for feature IDs. We don't want those. And we're going to go in and run these. And it's going to just run through the model. And because we're switching that close and completion, we don't see the end result of the whole script running. But that's not what we're interested in. What we're interested in is this thing here. So soil map, add to display, look at our map and the attribute table, and we see, I'm just going to sort of drop that to the bottom here, and we see in our attribute table a 0 and a 1, which if we sort of show this in color, it's going to look exactly how we would expect it to look. 0s and 1s. So the water, etc., that was unsuitable. The other area around that was deemed suitable. With regards to the buildings, let's add that to our display as well. Again, looking at the attribute table, just drop that down here. Don't seem to be combining, that's okay. We'll have them up on top of each other. This is our buildings here. We have the area that is unsuitable, which is the buffer around the buildings, and the area that is suitable, which is the areas in between. Looking at color, unique values, all others, and I'll give this color similar to what we have in the other one. That's a 0, so that's supposed to be something red, possibly even this one here. Wonderful. And this guy here, what we'll do is make it a shade of green. Beautiful. So that is how to assign values to your criteria. Just like that, within just under half an hour, we've created a model with 3 different criteria, which are almost all done. Remember, in order to union everything together, the reclassify, or the raster set of your analysis needs to be converted to vector. But that is something for a different tutorial. Thank you very much for your attention. If you have any questions, as always, make sure to either bring them up in class during a practical, send us an email, or ask your question on Teams. And we'll see you out there. Best of luck.